It's all done. Now let's start. So remove this layer. You guys already quite familiar with this screen, right? I wonder if you can see this screen properly, or is it too small? I think it can be too small. Let me try to somehow there must be a way to change the resolution. Display. I think this is the one. Unfortunately, I can't find a way. What about this? Does it work? No, not at all, right? No, sorry about that. Yeah, let's just do it. Fine, change the resolution. No, it really doesn't change any resolution here. Give me 1 second. If I do it here, change the resolution. No, doesn't work. Sorry about that. Let me just do it this way, and I will explain you one by one by my mouse, so you can follow it anyway. So first, please download the files from the database that from the Google Drive that I provided. If you download them and unzip them, you should be able to see all those files and directories as well, which include VM, infrastructure, and processed area, protected area, road, solar, and urban area, and wetland. Is that correct? Can you see them? Okay. Maybe let me share this way. This can be slightly better for everyone. This looks better, right? Okay, I think this should be better. A bit smaller scale, yep. Okay, I think I figured out a way to share in a better format. Okay, sorry about this mess. Because share this screen and then having this. Yeah, this looks much better now. I think we have all the things here. Okay, first, what we are going to do is opening the base map. So you guys can open base map whatever you like. Usually I put those in XYZ tiles, or you can find them somewhere. Where was it? Must be somewhere plugin, and then you can go somewhere. Can't remember, because this is not the way that I use. Okay, here is you can use quick map or quick map OSM standard, or in my case I put them in XYZ tiles so that I can just drag and drop from here. So let's open the base map. And then let's zoom in to South Korea. Sorry about this, guys, because I only have data for South Korea at the moment, and I'm really familiar with South Korea. That's why I'm using South Korea as case study. But basically, all the other things are exactly the same. All the technical things and data are basically the same. And what we are doing is to understand how to use QGIS. So doesn't matter where we do. And later, if you guys have interest in building this on your own country, and when you are doing it, if you have trouble, please let me know. Definitely, I can help you guys in person. Okay. So this is South Korea. The first data we are going to add is going to be jeju-base.gpkg. So you can drag and drop it to here. Let me know if you have done it. So now we can we can basically zoom in, right? We are going to try different techniques here and there. So probably is going to be a bit repetitive, but it's fine. Zoom to layer, then we can see the vector layer, right? The order of the layer should be the vector, and then OpenStreetMap should be on the bottom so that you can see it. Okay, but at the moment, what we want to do is checking if this vector layer is correctly set or correctly made or imported or not, because that's the process you need to check every single time. For that, what I do is right click it and go to properties. Then you will see this screen, right? This new window, right? Usually I set the color something which is very distinguishable, something very red or very blue, something like that, or very strong green. But let's use just a red at the moment and then make it a bit bright. And another thing, what you need to do here is changing the opacity to say something like 50% opacity. And then you can click OK. Now you can see the base map, which is overlapped with your Jeju base vector map. Can you see this? Okay, now what we want to do is whenever you import vector to the map, the first thing, never forget, the first thing you need to check is if this map has correct CRS, which is so to check it, so basically coordination. So how do you check it? What I do usually is I choose an island which I know. Right? In this case, I'm going to choose an island called Udo. This is an island called Udo. Some people say this is called Udo because U in Korean or Chinese Korean means cow or cow. And some people say this island looks like cow. So, but not from this side. But if you see like horizontally, then it looks like a cow is sitting. So people say this is Udo. Anyway, the point is, if you zoom in, not too much, but just amount about this, and you can see the shoreline, right? If we zoom in even more, you can see the shoreline. I mean, it doesn't need to be perfectly aligned because this vector is developed by one institute, and this OpenStreetMap is based on the satellite data, so they can't match it exactly, right? There is a mismatch always. However, as far as you can see, the overall picture is similar. It's fine. So for example, if we zoom in here, you can see there is a road and seems it's quite well aligned, right? When I say it's aligned, if we check the distance between those 2 points, it's gonna be about 2 meters, or maybe less than 2 meters, about 1.5 meters or something. So it's fine. You can just ignore it. So you can assume this CRS of this vector file is correctly set. So what happens if there is a wrong CRS? Let's try to change this CRS. Okay, you can right click it, go to layer CRS. I'm doing slowly here, okay? And then you can go to set layer CRS. Then you will be able to see this kind of thing. This new window, right? All good? And we will change this CRS to something else. Let's just type Korea. There are multiple different types of CRS which is for South Korea. Even South Korea has many different type of CRS, which can be classified the date when it's made, or sometimes it can be distinguished which point is a reference point. For example, this map, this one CRS can be focused on the west side or east side or north or south or etc. etc. There are lots of different CRS. So let's try to change these to something like, this is unified CRS at the moment. So let's try to something else. 5181 and click OK. Now what happens? The vector is gone, right? If we zoom out, can you find it? Can you find the vector? I'm not sure. We can zoom in. You can zoom to the layer. It is somewhere. Yeah, if you zoom to the layer, you can see somewhere in Russia. See, this is the problem when you set a wrong coordination or coordinate. I think CRS, yeah, coordinate, right? So you must check every single time, because some CRS system has a difference only maybe 50 meters or something like that, right? Particularly for those countries with smaller land area, there is big chance that you guys have a different CRS with very similar, however slightly different. But unfortunately, not all those data managers understand the importance of the CRS. So in many cases, including Korea, those people uploading this data forget to upload the CRS data set, which is basically metadata set. They forget to upload it, but just a vector. In that case, you have no idea where this vector, I mean, QGIS have no idea where this vector should be located, right? So you need to move around. You need to check the map and then vector, and then you need fix this layer to something that you know. I mean, this is all based on your like experience. I can't tell you how, but if you have enough experience on changing the CRS from one to another and back to the first one or one to second one and third one, if you have many experience, if you gain enough experience, as you see this vector data, you will know what CRS it is used based on the gap between the base map and the vector you just imported. Does it make sense? Okay, so because I know what CRS of this data of this vector set, um, which is 5179, unified CS of South Korea, made in 2000, because we know that we can play with it. So try to change this CRS to something else and then see what happens, and try to come back to 5179. I will give you maybe just 1 minute for this. I will wait here 1 minute. So try it and let me know if there's any question. And together with the shoreline, so another thing that I check is actually an infrastructure, like really big infrastructure. In this case, this is port. In case of port, it is definitely seen from the satellite, right? It's clearly seen from the satellite because it's large enough. At the same time, most of those vector data include those big infrastructure shape as well. So you can double check, you can check if the map is correct or not using the satellite. And unlike shoreline, these infrastructure data set usually have very like unnatural shape, like very, how do I say, like 90 degrees angle, or like that very human like angles, right? Which is not really natural. So it's easy to figure out the problem of the data set using, if you use the infrastructure. If you already tried changing those CRS from one to from the current one to another, and you managed to successfully came back to 5179, then try to zoom in and out some places to see if this data set is well organized and well matched with this base map. Okay. Now everyone is on 5179, right? The same condition with me. Now let's move to slightly east and north part of Jeju Island. So if you see the entire picture, entire map of this Jeju Island, you can see this bit north and right side. Let's zoom in that part, particularly just about this much. It doesn't need to be exactly the same, so you can just rule of thumb about this resolution. The scale is about 80,000, 1 to 80,000 is the scale that I have here. Everyone is here? Okay, now what we are going to do is we will find a function called create layer from extent. You can see here, create a layer from extent. What this is doing is we are going to create a new vector layer based on the map we have, okay, based on this extent that we have. So just click it, then you will see this. And what's the extent? Of course, you can type in the number xy, x1, x2, y1, y2, or something like that, but you can simply click this button so that it gets the extent from the map layer. Okay, see, all the information is here. And we are going to create it. Cannot see anything. It's just all covered. Everyone is following here, right? If we zoom out just one more step, just one step, if we zoom out, you can see this map, that there is a square box, which is exactly the same size of your screen, of your map window, right? What we are going to do is we are going to then flip. The reason that we are doing this process is because we want to focus on the area where we have an interest in. And I assumed that we have interest in calculating the renewable energy potential of this square box area in Jeju Island. Okay, then we are going to clip Jeju base with the extent we have. Then we are going to save this file as a whatever you like, but usually I use geo package. And then we gonna go to here. Yeah, let's just make it here. A new folder. I'm going to share this file together with you, so later you can have a look at it. And then working 6 and Jeju. I'm going to name it as Jeju clip and make sure this is geopacked file. And layer name, always I put exactly the same, Jeju clip. And then you can run it. If we close it, now we have the Jeju base map or Jeju base vector. Now we can see this green area, which is basically based on the Jeju base map, but flipped by this extent layer. Okay, so I'm gonna do all of this process again from the beginning. Going to remove all of these. Then we can zoom about this size. This is what I need. This is the area that I want to analyze, right? So we can type create layer from extent. I mean, there are different ways that creating a new layer, but this is the way that I want to use for this class. Okay. And what's the extent? Extent is basically x1 and x1 and x2 and y1 and y2, like basically the scale area is called extent. We are going to just use the map or canvas extent. If you click this button, then it will import the extent of your canvas. Right? You can run it. Now we have this extent, a new layer called extent. Then we will do the clip. Clip is basically clipping. Clipping input layer using the overlay layer. That's what it does. We are going to clip Jeju base using overlay layer, which is extent. If you do it, you will use this overlay layer and then make sure you only have the overlaid or duplicated layer between input layer and the overlay layer. Does it make sense? It's basically similar to what is that? There's some these days I forget the word sometimes. Not clipping, but anyway, I will have a look at it again, and then yeah, that's what you need to do, and then run it. Then you will have clipped area. Okay, so yeah, the one I wanted to say was intersection. Yeah, intersection. Almost the same with the intersection. However, the difference is this one actually clips out. But in case of intersection, it finds only the intersected area and then returned all the information that both vector layer has. But in case of clip, it will only have the base layers information and then ignore the information of extent when you open the attribute. Okay? So yeah, we have clip. And then because we have this clip data, we don't need extend and Jeju base. We are going to remove layers. Now this is the layer we have interest in. Maybe we can make it a bit more transparent, 50%. Okay. Okay, try it on your own and yeah, let me know thumb up if you are following so far without any problem. I can repeat once again. Okay, let's remove the layer. And then let me have Jeju base. Okay. This is the Jeju base we have, right? And we wanna analyze about this area. Okay. We will create a layer from extend. Create a layer from extend. Okay. I'm gonna do it very slowly, step by step. So probably you can just do it together with me. Double click it. Okay, I'm going to wait here about 10 seconds. Okay, now we want to use the extent of your map canvas, right? This area is called the map canvas. We are going to use that part. So the best way is just click this set to current map canvas extent. Just click it. And then run it. If you close it, you're going to be able to see this new layer, which has a exactly same extent of your canvas. Now we will clip it. You can clip. Input layer is Jeju base. Overlay layer is gonna be Jeju extent. I think it should be okay to have different ways. Never tried, but should be fine because anyway there is no other information rather than just the size. And then you can run it. Then you should be able to have this new clipped area. And you can remove all the other layers. Okay, I think it should be really good to go for the next step. Now, what we are going to do is we are going to work on a road file. You can see the road data, and then drag and drop the shape file. Let's see. Here is the road data, and then you can drag and drop the shape file here. It's quite complicated, right? So probably for some of you, it might take a little time to import this older data set to your computer because it's kind of big. So good here so far. Everyone managed to import the raw data. Good, good, good. Thank you so much. And then if you zoom in and then hide this clipped data, do not remove it, just uncheck the clipped one. Then you can see those base map and the road vector is quite well overlapped, right? Just look around. Seems it's quite fine, right? They are well matched, aligned quite well. And also, if you can see those road near the shoreline, make sure there is no road running on the ocean, something like this. If you see this, you need to double check it what happened to this. I don't know, maybe there is new land area here. I don't know, maybe a bit small port or fishery area, something like this. I'm pretty sure there must be some more like extended area here, like infrastructure similar to this one. Those are fine. Usually those are fine. But if you see a long entire road is like going through the ocean, you needed to make sure if there's a bridge or if there's any kind of infrastructure which explains the situation. Usually I go to Google Map or Naver Map in South Korea and then check it with the map. Okay. Now, what we want to do is we are going to click once again, let's rename this clipped data set to something else. Let's just where is it? Export. Let's export the feature and then select the file that we've been working here. So to clip version 2, and then it's like weird. I don't know what happens to this Mac. So you click the V2, and then you can just run it. You have new clip data, and then remove this old layer. Then we will clip once again, but this time we are going to clip the road because we only have interest in this area. But if we apply all the analysis to other area, including basically entire South Korea, it will take such a long time, right? So we are going to clip this road once again using a Jeju clipped data set. Now we are going to save it to here, road clipped, road clipped. So what you need to double check, what you need to make sure, or what you need to notice here is the input layer is road, right? However, in case of overlay layer, we used the extent, right? Before we used extent. However, now we are using the Jeju clipped, which is basically the clipped Jeju base using using the extent layer. So this way, we can basically exclude those roads out of the base layer, right? So that's kind of benefit that we can use, we can take and just run it. It might take a little longer time than before because the structure of this road is much more complicated than the base map. Close it. And now you can close this road. N3A, A0001, 0000, whatever, you can remove it. You have the road, the road data here. Now let's uncheck Jeju clipped and let's see if they are clipped properly. All you need to check is if this line is properly clipped. It's all correct, right? Okay, I'm going to stop here for about 1 minute. Have a look at it and then try on your own. And if you want me to repeat, please let me know. I'm going to repeat. Remove the, no. This better. So first you need to import the road data. And you have Jeju clipped data, which we clipped or which we created just before, right? And make sure all data is imported correctly. And then you need to clip it. Second, yeah, you need to clip it, but this time you need to be very careful. First, input layer should be N3A, which is the road data, and the overlay layer is Jeju clipped. That's it. And then, of course, you can save it to geo package or shapefile, whatever you like. But usually I use geo package. Oh, sorry, I didn't supposed to ESC, hit the ESC. So N3A and Jeju clipped. And then run it. Then you will have this clipped road information. And there is a question from Aisha. I just realized that when I export the data from temporary clipped data, the CRS is not the same as original data. Is that okay? Yeah, it's okay. Usually, it should be all okay as far as the place the same. What just happened is, okay, when you um so what usually happens is when you export, like for example, when you export it, you can set the CRS, right? So probably the CRS was different, but in this case, this will definitely in this case, QGIS will use this CRS, but will not change the location. However, the CRS will be set, or this CRS will be used to describe the vector that you are saving. So you can reassign the CRS later if you don't like it. But in my case, whenever I import data, if I have enough time, I reset the CRS to the same one always, every time, just to make sure that it works fine. Okay. Next thing that we want to do is go to road clip, remove it, remove the layer, go to road clip. Okay. And we are going to set the buffer. Here is very interesting part. In many cases, or not, I would say almost all, but in many countries, there are regulations that restrict building solar power or wind power within certain meters or kilometers of houses or road or any infrastructure. Like in case of South Korea, the restriction can be as small as 50 meters, but up to about 1 kilometers, depending on the council. There are 200 and something, 230 small councils in South Korea, and each council has different value. So we are going to mimic the regulation. Usually, the regulation should be applied to large road or wide road. But in this case, because we don't have that much data at the moment and we don't have time, we are going to just apply it to entire road. But if you apply 100 meters to the entire road of this area, then there is going to be no area where we can build solar power at all. So we are going to apply just 10 meters, which means within 10 meters from the road to each side, that nothing can be built. Okay, let's run it. Did I do it correctly? Yes. You should select road clip as input layer and then remain the others as same. You are not going to change much anyway in the future. But when you become pretty much advanced or expert of QGIS, you can change all those things as you wish. And then let's zoom in and drag the buffer below the road clip. As you can see, there is a bit darker or brown area which has the distance about 10 meters, right? It should be exactly 10 meters, but because I can't really snap the correct position, it seems correct, right? 10 meters to each side of the road is set as buffer. Everyone is here? Are you guys doing so far? Or do you want me to do it once again? Let's just do it once again. Okay, let's go to buffer and then choose road clip and then distance 10 meters and then run it. Then you have this. Then we are going to save this buffered as a um something else. Road buffered. Are you guys all here? Yep, great. Thank you. Thank you. If you are not able to save it so far, it's fine because I'm going to share the file and the video so you can have a look at it later. The last one that we are going to do today is if we want to build solar photovoltaic, we should remove this buffered area, right? So we will use difference. In this case, we are going to use the vector overlay difference. You can just type difference and then go to difference. The input layer is going to be the Jeju clip. The Jeju clip is the entire area where we want to analyze if there is enough solar potential or not, right? So we are going to use Jeju clip V2, and then overlay layer is road buffered, which means those road area with buffer should be removed from the analysis area. We are going to save it as a Jeju clip, no, Jeju road, yeah, which means Jeju minus road. And step one, because we are going to have about 4 or 5 different steps, so we are going to save each step as a geo package. That's how I work. Every single step, I save the file so that I can go back, right? And then Jeju, same name, Jeju road, step one. Now this is one you should have. Jeju clip as input layer and overlay layer is road buffered, and then you are going to calculate the difference. And if you run it, ta-da, where is it? Road buffered. That's what we have. Choose the layer. Now you can see basically what happens is, ta-da, this is the Jeju area where you can build solar photovoltaic at the same time without having trouble with the road area. So you can the area. So basically, you can obey the sort of a mimicked or assumed rule that solar photovoltaic cannot be built within 10 meters of the road.